Hi, my Math 130. So today I'll be covering homework alternate chapter 8 and 9. I'll be covering a few of those problems. Let me go ahead and write this out. So today, this is technically for week 14, lecture 1. And in the first video, I'll probably get through numbers 1 through 5 since they're similar topic. And then I'll take a pause and then keep going throughout and just making different videos. So let me save a picture of that. Let me go ahead and clear this out. For numbers 1 through 5, we're going to be dealing with operations of functions. Let me share a whiteboard with you now, so I have more room to do this. Don't know why this never works. I'll stop sharing and start again here. Here we are. Okay, so for chapter 8 officially, operations with functions. And this covers numbers 1 through 5 in the homework alternate assignment. Okay, so essentially for this, what we will need to know, essentially we can have two functions. One we're going to call f of x, and the other function is going to be g of x. Okay, we're actually going to look at some function rules today. So first one, what happens when you add the two functions together? This is addition, property of functions. So essentially we're going to be looking at a third function, f plus g of x. What that function is going to be equal to is the function f evaluated at x plus the function g evaluated at x. Okay, so this is one of our rules. Okay, the second rule, subtraction property. Of functions. So for this one, you're going to be taking f of x, subtracting g of x. And what that gives you is your new function, f minus g of x. Third one is multiplication. You're going to have f times g x. Notice that this is a solid dot. Okay, it's not a hole. It's going to matter in a minute. Sorry, going to matter in a moment. And then that's going to equal the function evaluated at x multiplied by the function g evaluated at x. So go ahead and take a picture of those, and then you can also just pause the screen and write them in. You know, I kind of want to write these all on the same page, so let me try to do something here. Let's see. Okay. Aha. All right, great. So let me write my last rule in here for the basic operations, and then we'll actually practice a few problems from the homework assignment first before we go into composites. So division property, functions, you're going to have f divide g of x, and that will be equal to your function f evaluated at x divided by your function g evaluated at x. Now for this part, you need a condition, because remember, you never want your denominator to be equal to 0, otherwise you have an undefined function. So g of x cannot be 0. Put a little note here, or the function f divide g of x will be undefined. And let me change my wording a little bit. Let me put otherwise. So if if g of x equals 0, then that means my denominator equals 0, which would make this larger function undefined. So now I'll go ahead and take a picture of that. I'm going to save this myself. And then we're going to look at numbers 1 and 2 from your homework assignment. Okay. All right, so let me just keep that open. Hopefully I can do a new share without it messing up again. Let's see. So far, not off to a good start. There we go. Okay. So let's start with number 1. Play around with these windows a bit here. Okay, so suppose that the functions f and g are defined for all real numbers x as follows. So let's color code this a bit. F of x is going to be in orange, like we had it before, and g of x is going to be in blue. F of x is defined as the function f of x equals x minus 3, and g of x equals 4x plus 6. Write the expressions for f plus g of x, f times g of x, and evaluate f minus g at 4. Okay, let me write that in here. Okay. So let's call this number 1, number 2, number 3. Actually, let's call it A, B, and C so we don't get mixed up with the numbers here. A, B, C. So for part A, trying to find f plus g of x. Always start with your general definition. I know that that's going to be f evaluated at x plus g evaluated at x. Okay, so what that tells me, f plus g of x is going to be equal to the quantity x minus 3, okay, plus the quantity 4x plus 6. Okay, so now keep your equals here. What you're going to do is just drop your parentheses for the first bit and then distribute appropriately. This is a plus, so we're just going to drop parentheses on the second factor too. And then combine like terms. So we have 5x plus 3. Okay, so for this first box here, 5x plus 3. Okay. Part B, we have f times g of x. Remember your general formula first. That's f evaluated at x times g evaluated at x. Okay, so f times g of x is equal to, we have f of x, the quantity, times g of x, the quantity. Okay, so for this one, you're going to want to FOIL. You're going to get 4x squared plus 6x minus 12x minus 18. Like terms in the middle, 4x squared, 6 minus 12, that's negative 6. Still have x connected to it, and then minus 18. So our second function is equivalent to 4x squared minus 6x minus 18. Let's take a look at part C. We want f minus g at 4. I'm gonna actually give myself some room for this. Let me save this. And then let me clear this portion of the screen. Oops. Okay, so for part C, let's do this in green. Okay, no. There's actually two ways to do it. When x is replaced by a number. First way, just remember your general rule, f minus g of x. That's going to equal f of x minus g of x. Now, if you have a 4 in there where x is located, you're evaluating f at 4 and subtracting g evaluated at 4. Okay. So that's your first method. Oh, actually, let me be more specific with that. Okay, so this would be your first method. If you already know that x is going to be 4, you just plug 4 into f, plug 4 into g, and then you take the difference. Okay. The second method would actually be to find f minus g of x in general. And then plug in x equals 4. So I know like the way I wrote it, it really sounds like I'm writing the same thing, but it's not. So let me go ahead and clarify. Let's start with the first part. So I know that x equals 4, right? Let's go back to color coding. So f minus g at 4 is going to give me what? Okay, we'll start with your general. I know that I'm going to have f at 4 minus g at 4. Okay, now f at 4, that means plug in 4 for x. So we have 4 minus 3, the quantity, minus between, and then g at 4, that's going to be 4 times 4 plus 6. So let's simplify algebraically. First bit, if you know where you can cut corners, you can do so. But just in case, let's go step by step. So 4 times 4, that's 16 plus 6. Let's simplify inside the parentheses. That's going to be a positive 1 minus 22. So we actually get 1 minus 22, which is negative 21. Okay, so there's our answer, but let's find out how to use the second method, which is just to find the general f minus g of x first, and then to plug in x equals 4. Order matters. Okay. Let me save that and then erase this. So your second method, you're going to find f minus g of x first, and it's defined to be f of g minus, oh my goodness, no. Oh, come on. Okay, sorry about that. So it's defined to be f evaluated at x minus g evaluated at x. Okay, so f minus g of x will be equal to x minus 3, the quantity, minus 4x plus 6, the quantity. Now, this is actually a good way to go over this. It's kind of important to know for later. First bit, you can drop the parentheses. But now you have a distribution here. What color to use? Let's use purple. Why not? So you have a distribution. So after the distribution, you get negative 4x minus 6. Combine your like terms. Negative 3x minus 9. So what that tells us is that f minus g of x is negative 3x minus 9. So that'd be useful if you needed to find f minus g of x first, and then you were asked this. But yeah, you can see that it's going to be a little bit longer for this method. Now we'd have to plug in x equals 4. So f minus g evaluated at 4. We have negative 3 times 4 minus 9, which is negative 12 minus 9, which is still negative 21. Okay. So it's kind of up to you how you maneuver that part. Okay. All right, let me clear this out, and then let's do number 2. Okay, so suppose that the functions f and g are defined as follows. You have f of x equaling 2x squared minus 5, and you have g of x equaling negative 3x plus 4. Thanks for bearing with me a bit with these colors. Like, I know that it's kind of taking me a lot more time to do it, but I think it's more important to color code. Let me know if you have any opinions on this. I would love to know, just to know if it's actually helpful. Okay, so you have your two functions. You want to find f divided by g evaluated at 5. And then you want to find all values that are not in the domain of f and g. Okay, so for this one, I'm going to give you a hint. Because you are asked for domain exclusions, just meaning values that aren't in the domain, okay, of your function. You want to find f divided by g of x first in this problem before part A. So before finding f over g of 5. In my experience, it just saves you some time, but might not. Just try it and then let me know. So if I wanted to do just part A, I'd plug in 5 to my f of x here. I'd plug in 5 to my g of x, and I would take f, whatever that value was, and divide it by g. But for the values that are not in the domain, you need to know what your function together is going to look like. So for this, let's actually start with part B. And I'm going to put, I'll start with it because that's just a personal preference thing. You would need to do it that way. Okay, so f divided by g of x, the function, will be equal to your function f of x divided by function g of x. And the exclusions come from when g of x is equal to 0. But essentially, remember what that means for your rule is that you want to set g of x not equal to 0. We'll get into that. Okay. All right, so f divide g of x is equal to, we have 2x squared minus 5, the quantity, divided by negative 3x plus 4. Okay, and essentially, that's our general function f divide g. Let's put the exclusions in red. Let's do it in like a deeper red too, so you know it's not wrong. It's just like a, oh, that doesn't really look red at all. Whatever, brownish red. So the exclusion is coming from when is g of x going to be equal to 0. Okay. The fastest way to solve this, go ahead and put g of x not equal to 0 so you know that those are the excluded values. Solve down for x, and the exclusions come from x cannot equal whatever rule. It's probably gonna look a little messy because there's a lot of overlap with the wording here, but let me just see if I can move all this up smoothly enough. Yeah, okay. All right, so essentially the exclusion here is going to come from this particular inequality. G of x, which is equal to negative 3x plus 4, set that not equal to 0. Okay, so specifically put a don't equal sign between. So what we're saying is negative 3x plus 4 cannot be equal to 0. Otherwise, our function's undefined. Solve back for x. Okay. So the value that's not in the domain of f divide g is 4 divided by 3. Let me save a picture of this. Okay, I'm gonna erase this stuff. And just one more thing about the exclusion. Essentially, what it's saying is when x is equal to, let's put this over here in exclusion color. When x is equal to 4/3, g of x, aka g of 4/3, is equal to 0. Which means f divide g of x will equal your function f of x divided by 0. Okay. Which means f divide g at 4/3 is undefined. One more change I want to make because we actually plugged in x before. So when x is 4/3, plugging in 4/3 to f and g would give you this kind of situation. One more thing. I want to plug in that x everywhere. We'd have f evaluated at 4/3 divided by 0. So let me know if you have any questions about that part. I went ahead and saved that part picture. So let me erase the bottom and we're going to go over part A. Okay, so now part A, we want to find f divide g evaluated at 5. Okay. Remember, you have multiple methods for this. This will be f evaluated at 5 divided by g evaluated at 5. Or since you already saw what f divide g of x was, that would be 2x squared minus 5 divided by negative 3x plus 4. You just plug in x is 5. Okay, it's really doing the same thing, honestly. Just depends on how much time it takes you, depending on the way you think about it. So essentially here, f divide g at 5, it's going to be equal to, you've got 2 times 5 squared minus 5 divided by negative 3 times 5 plus 4. Okay. So that equals, you just make those equal signs the same color, save some time. All right, we're going to have 2 times 25 minus 5 on the top. Divide negative 15 plus 4 on the bottom. That gives you 50 minus 5 divided by negative 15 plus 4. Which equals 45 over negative 11. Okay, so for f divide g of 5, we actually get negative 45 elevenths. Okay. All right, that covers the first 2 problems and operations with functions. The first 4, we're going to cover composites separately. So I've already taken a screenshot. I'm going to stop this video and then just start a new video with composite functions next.